Here's a real-time example of statistical inference and hypothesis testing. Suppose a company wants to test whether a new advertising campaign has increased sales of their product. They collect sales data for a month before the campaign and a month during the campaign. The data shows that the average sales per day during the campaign was $100,000, compared to $90,000 before the campaign. The company wants to know whether this difference is statistically significant, i.e., whether it is likely due to chance or whether it is a real effect of the advertising campaign. To do this, they can perform a hypothesis test. The null hypothesis is that there is no difference in sales before and during the campaign, i.e., the mean sales per day are the same. The alternative hypothesis is that there is a difference in sales, i.e., the mean sales per day during the campaign are higher than before. To test this hypothesis, the company can use a t-test. They calculate the t-statistic, which measures how much the sample means differ from each other relative to the variability within the samples. The t-statistic turns out to be 2.0, which means that the difference in means is 2 standard errors away from 0. They then use a significance level of 0.05, which means they are willing to accept a 5% chance of rejecting the null hypothesis when it is actually true. They compare the t-statistic to the critical value from the t-distribution with n1 degrees of freedom, where n is the sample size. If the t-statistic is larger than the critical value, they reject the null hypothesis and conclude that the difference in sales is statistically significant. In this case, the critical value is 2.042, which is smaller than the t-statistic of 2.0. Therefore, the company fails to reject the null hypothesis and concludes that there is not enough evidence to support the claim that the advertising campaign increased sales. This example illustrates how statistical inference and hypothesis testing can be used to make decisions based on data. It also shows the importance of choosing an appropriate significance level and understanding the assumptions underlying the statistical test.